afternoon. My name is Faber. I am I'm the lead organizer for the Africa IoT and AI Challenge in Kenya. I welcome you all to this afternoon's training session that will be led by Gearbox, by Mr. Latif Charona and his team. And we also have some representatives from IEEE as well. So I welcome you, Latif, to take it up from there. Thank you.
Great, thank you, Faber. Great, thanks, Faber. So as you are aware, Gearbox is the technical partner of the Africa IoT and AI Challenge. And our capability is in the prototyping hardware space, also in training of IoT, embedded systems, and a lot of future-facing technologies. So I will hand over now to the team that will be doing the training over the next 4 days, covering the basics or the fundamentals of machine learning, AI, digital fabrication, to help all these startups that are in this challenge be better equipped to perform to the best of their ability. So on this, I will hand over to Ngugi to take us through the training. Thank you, Ngugi.
Hello, how are you all doing? I hope you had an amazing day.
Yes.
My name is Ngugi. I run Gearbox Academy, where we focus on aspects of training on Industry 4 technologies with a mix of human-centered design. So I'll give a brief introduction of who we are in Gearbox, what we do, and how we came about with the Academy. So as Latif has mentioned, we are a prototyping space. We focus on a lot of design and fabrication on both aspects of mechanical, electrical engineering, PCB fabrication. Over time, we have been building a lot of products, supporting a lot of startups, and we've been able to build a wealth of resource, not just in equipment, but also in personnel. People who are really brilliant in what they do and build practical and relevant solutions. So on Gearbox Academy, we saw a huge gap in the academia, between academia, schools, graduate programs, and the working industry, the real working industry. So we have been working to bridge that gap so that students gain practical and relevant skills in a way that they not only are well placed to join the market, but also come up with innovative solutions that grow into businesses and enterprises. So it's a pleasure to have all of you. Today we are going to have a training program based off on the fundamentals of machine learning. I have my team members with me. First of all, before I introduce them, the format is going to be going through some presentations, some slides, document which is going to be shared later on after the call for review and analysis for the students. So there is Patrick Limo, there's Evelyn Otieno, and there is Maxwell Washira. So I'll let them introduce themselves in that order, starting with Patrick, then Evelyn, and finally Maxwell.
Okay. Hello. Okay, I'm Patrick Limo from Gearbox, Kenya. Yes.
Good afternoon. I'm Evelyn Otieno from Gearbox, Kenya. Thank you and welcome for the training.
Good afternoon. My name is Washira Mwangi, and I'm also from Gearbox.
So thank you for the introduction. Patrick is going to start off the session. So Patrick, I'll hand it over to you, Evelyn, on this session. I think we are going to have about 45 minutes of going through the content. We were meant to have a Q&A, so yes, I shall let Mr. Limo take over.
Okay, thank you. So allow me to share my screen. Okay, I hope everyone can see my screen. Just a minute. Okay, cool. So I'll be doing training in an overview of machine learning, whereby we'll be seeing through the introduction to machine learning, whereby I will take you through the course from the introduction to machine learning, whereby we'll be checking through the artificial intelligence, machine learning, deep learning, data science, because it is good for us to understand the difference between them before even we start checking what is machine learning. So straight away, I'll be doing the introduction to machine learning, checking through the supervised learning, unsupervised learning, reinforcement learning. That's just an overview. Whereby also we have Evelyn doing the basic programming in Python, and also Maxwell will come in do deeply concerning the supervised learning, unsupervised learning, reinforcement, and statistics and probability. So without wasting time, I would like to start differentiating between the artificial intelligence, machine learning, deep learning, and data science, because you find most of the people normally confuse them. For instance,
Can you hear me?
When we talk of artificial intelligence, we'll be talking on how the machine focuses on becoming intelligent, just like trying to mimic the human behavior. So as you can see there, it's concerned with impacting human intelligence.
Can you hear me?
Hello, can I go on? So let me share just a few minutes, share my screen also. So I was talking about the difference between machine learning, artificial intelligence, and deep learning and data science, because you find most of the people normally confuse them. So I was talking about machine learning, and once you are going to note the difference between machine learning, AI, deep learning, and data science. So we'll start with artificial intelligence, whereby they focus on the development of intelligence machine that can think like and act like humans. Also, artificial intelligence is it's all about mimicking the human behavior. But when it comes to machine learning really focuses on really concerned with the giving machines the ability to learn by training algorithms on a huge amount of data. So you find it's always about statistics and algorithms for machine learning. So there's difference between artificial intelligence and machine learning. And machine learning, it's under artificial intelligence. It's a subset of artificial intelligence. Also, deep learning is a subset of machine learning. Deep learning, it's an approach to machine learning, one that focuses on learning data representation rather than on task-specific algorithms. So this uses what you call deep neural networks, which was inspired by the structure and functioning of the human brain. Now, there is a huge difference between deep learning, machine learning, and also machine learning and artificial intelligence. But deep learning is a subset of machine learning. Now, going to data science, it's a term, when it comes to data science now, it's a term for a whole set of tools and techniques by which to analyze data and extract insights from it. It makes use of scientific methods, process, and algorithms to make things happen. So as you can see, we have difference between AI and machine learning, deep learning, and data science. I hope that's well understood. Now, we are narrowing down to artificial intelligence, whereby we are going to check in artificial intelligence also, we have classification of AI. That is an artificial narrow intelligence, artificial general intelligence, artificial super intelligence. That's for artificial intelligence. And this classification of artificial intelligence, let me define them quickly. And for the one for artificial narrow intelligence, we have a narrow AI is call oriented and it's programmed to perform a single task, and it's very intelligent in completing the specific task that is programmed to do. But for artificial general intelligence, it's also referred to as the strong AI concept, which is machine exhibits human intelligence. These are still under research, and also the one for artificial super intelligence, still under research. This is where machines will be able to exhibiting intelligence that surpass the brightness of humans. So the second one and the third one is still under research. For those are just classification of artificial intelligence. We are now going to types of artificial intelligence, where we have the reactive machines, we have limited memory, we have theory of mind, and we have the self-awareness. So with the interest of time, I'm just going to divide them very quick. For the reactive machine, they do not store memories or learning from the past experience. They simply react to the surrounding and choose the most optimal solution among the available alternative. That's for reactive machines. But for limited memory, machine retain data in a transient manner, meaning that its memory lasts for a short period of time, much like a cold fish. Now, this meaning that the memory lasts for a short period of time. Well, that's for limited memory. But for theory of mind, the theory of mind, we say that this is a type of the AI that is yet to exist. It's still under research also. The purpose behind building such an AI is to have a computer that can simulate human emotion, beliefs, desire, and impact to future decision. And the last one, we have what you call the self-awareness. This is still under research also. This is what is meditation and spiritual stuff in the mindset of artificial intelligence now. To honor that, let's understand the self-awareness. When an individual has conscious knowledge of their character and their own feeling, he or she becomes self-aware. And AI is a self-aware when it is able to form representation about itself and thus be conscious about itself. A self-aware machine will understand its current state and use the information to infer the emotion of others. So that's still under research also. So application of artificial intelligence, we have artificial intelligence in automobiles, artificial intelligence in education, and so on. We also have examples of artificial intelligence, whereby we have the Netflix, we have Siri, we have the Pandora, we have the Flipkart, and we have the Echo from Amazon. That's it. That's it for machine learning. So in that's it for artificial intelligence. Sorry. So artificial intelligence, we have the classification of AI, we have types of AI, and we have the application of artificial intelligence. Now moving on to machine learning real quick. In machine learning, we have two different types of machine learning. We have the supervised learning and the semi-supervised learning. We have unsupervised learning and we have the reinforcement learning. So This is what will Maxwell talk about deeply, but we can just define for you just a bit. Like for supervised learning, it's used the labeled data sets to train algorithms to classify data or predict outcomes accurately. So also we have the algorithms for each and every types of machine learning. We have the algorithms for supervised learning, we have the algorithm for unsupervised learning, and we have the algorithms for reinforcement. And I think that's what Maxwell will talk about. Also, for the second type of machine learning, we have the unsupervised learning. But before we check on that for unsupervised learning, we can have a photo here, whereby talking of inputting a raw data, we'll be having an algorithm to tell what's happening. We have processing and we have the output. That's what will Maxwell cover. For unsupervised machine learning, this whereby like the use of artificial intelligence algorithm to identify patterns in a data set containing data points that are neither classified or labeled. Yeah, so we also have the algorithms of this type of machine learning, whereby we have what you call anomaly detection, we have hierarchical clustering, principal components analysis, we have the clustering analysis. You can check also the photo of that unsupervised learning, whereby we have the inputting a raw data, we have the interpretation, unknown input, unknown output, no training data sets. We have algorithm, we have processing, and we have output. So remember, there's a very huge difference between the supervised learning and unsupervised learning. And also, we are going to check on the reinforcement machine learning. So this is the training of machine to learn modes to make a sequence of decision. This is majorly used in robotics. Yes. So finishing up on machine learning, but we'll have a deep explanation concerning that by Maxwell. I'm now going to deep learning. Going to deep learning. So deep learning, we know it was inspired by the human brain. So deep learning it's an approach to machine learning, one that focuses on learning data representation rather than task-specific algorithm. It makes use of deep neural networks, which are inspired by the structure and function of the human brain. So this is all about that's all about deep learning. As you can see there, we have the neuron in our brain, and we have the neural network developed using AI. So they all have nodes. They all have nodes. As you check that photo of a neural network developed using AI, first of all, we have to input a node layers, and then from there we have the hidden node layers. So remember, for a system to be intelligent, we need more nodes. We need more hidden nodes of layers. And we have output nodes layers, and also it was inspired by the human brain. So cool. For that, we're going to check on the data science. Because data science is the use of scientific methods, process, and algorithms to make things happen initially. Its goal is to discover hidden patterns in raw data to help business improve and increase their profits. So we have the life cycle of our data science, which is always 6. We have the discovery, pattern preparation, we have model planning, we have model building, we have communication resource, and we have the organization. So we have also, before I finish, I would like us to check on deep learning versus machine learning. Now, we have to understand the comparisons of deep learning versus machine learning through their features. First of all, we have what you call data dependencies. When you check, we will find that deep learning will need a lot of data for them to perform well. But for machine learning, it may. Or yes, when we compare the deep learning and machine learning, we'll need a lot of data for deep learning and not machine learning. for also hardware dependencies is we need hardware of high computing power when it comes for deep learning, part for machine learning. We may not need as we compare them. We have also what you call the feature engineering, and this is the topic which might which might be the next learning area when it comes to machine learning. Because for our models to become more accurate and more accurate, we need to do what you call feature engineering. So for feature engineering, I'm going to read this. It's general process. In this, domain knowledge is put into the creation of feature extractors, also to reduce the complexity of the data. Further, to make a pattern more feasible to learn algorithm working. Although it's very difficult to process and it's time consuming and experts. Now for feature engineering, what the one which will do code when it comes to feature engineering is deep learning and not machine learning, because deep learning is more advanced and it's a subset of machine learning. Yes, that's okay. That's it. So I believe I'm done. So I would love Eve coming in to give us the basic programming in Python. But before that, I hope it's well understood, because for us to do machine learning, we have to know the difference between these. We really need to know that machine learning, it's not AI. Deep learning, it's not machine learning. Data science is not, it's not deep learning. But data science is just like the combination of all. So I hope it's well understood. Maybe later on I will come up with an example of machine learning. But because of the interest of time, now I'm going to invite Eve to come and tell us the basic programming in Python, because we really need a Python or any other programming language, but we'll consider Python when it comes to machine learning. And then later on, we'll have Maxwell doing the deep presentation concerning the supervised learning. And supervised learning, we have reinforcement learning. Yes, so that's it.
Good evening. I'll be taking us through basics basic programming in Python and machine learning. And I'll be so brief and quick about this. I hope everyone can hear me. Please share my screen also.
Yeah, we can hear you.
Can you hear me?
Yes.
Yes, you can hear you.
Okay. So an introduction to Python. Python is a general purpose interpreted interactive objective-oriented and high-level programming language. And it was developed in 1991 by Guido van Rossum, a Dutch computer programmer. That is just on the history of a brief history of Python. It was developed by Rossum. Yeah, and it is also a cross-platform programming language, meaning it runs on multiple platforms like Windows, Mac, OS, Linux, and Unix. So Rossum, the person who introduced Python, was a fan of comedy series from late 70s. Thus, the name Python was adopted from the same series, Monty Python's Flying Circus. So I'll take you through features of Python so quickly. Number one, Python it's an open source. It's free and an open source, meaning you can freely use and distribute Python, even for commercial use. And also you can be able to see the code and even can make changes to the code. It is also simple and easy to learn. It's much easier to read and write Python program compared to other languages like Java. Python is also a high-level programming language. We are never required to worry about how low-level activities like memory management, securities, etc., meaning it's a friendly language. It is also platform independent. On any machine like Windows, Linux, Mac, we are able to run the code anywhere. We write code only once and run on different machines. And there's this term called WORA, like W-O-R-A, meaning write once and run anywhere. So it is also portable. It is also portable. You can move Python programs from one platform to another and run it without any changes. For example, you can write a Python program in Windows, and then you can transfer and run it on a Linux platform, Mac, whichever OS you want to run on. Then it is also dynamically typed. There is no need to declare data type for the variables. It internally creates types referring to the values. Python is also object-oriented. As we defined Python initially, there was a term as object-oriented, as it supports class, object, data hiding, data encapsulated, polymorphism. If we've done something, a language like Java, then you can understand these terms. So it is object-oriented. It is also a procedural oriented, as you can make the program without classes if we don't need security. It is an interpreted language. When you run Python code, it automatically converts your code to the language your computer understands. You don't need to worry about any lower level operations. And lastly, it is also extensible, meaning you can easily combine pieces of C or C++ rather, or other language with Python code. We can improve the performance of the application using this feature. I'm going to share the slides later, so we'll see everything is in the slide. So, and advantages of Python, it is simple and easy to learn. Like the features and the advantages are more of the same. Then applications of Python, that in short, where Python can be used, it can be used on desktop applications, web and internet applications, database, games, machine learning, artificial application, among others. And now when integrating Python and machine learning, because while we are interested in learning machine learning, we are going to use Python as our programming language. So these are the libraries, but there are many, of course, there are other libraries under machine learning Python, but these are just but a few. The three major ones, we have scikit-learn. This is widely used for machine learning. It has excellent online documentation. It supports most of the supervised and unsupervised learning algorithms. And Patrick has taken us through supervised and unsupervised learning algorithms. Then we have Skype. It contains different modules for optimization, linear algebra, and integration and statistics. Then we have NumPy. It's a very popular Python library for large multidimensional array. For example, while now writing on NumPy, the example is down there, import NumPy as NP. We'll see all these after installing the softwares that are needed to run Python. And then down there as I finish, we have a link to Python installation. For those who've not installed, I'm going to share the slides. So from there, we'll get the link to install Python and also PyCharm. I use both Python and PyCharm. PyCharm is an integrated development environment. I'll also share a link on the same. And my presentation is as brief as that. In case someone has a question, you're welcome to ask.
Hi, Evelyn. I think I'll first of all summarize, do my presentation, and then we can proceed to the Q&A.
Okay.
Okay, I believe you can all see my screen. Actually, what I'm supposed to talk about, Patrick and Evelyn, they've already talked about it. So I think I'm just here to give a summary and maybe just to put emphasis on one or two points. So I think I love using examples. So I will start off by giving this example. Yeah, I just want to, I think examples help us to understand much better. So let's assume that we are embedded systems engineers. We are tasked to make an automatic air conditioning system. So just like if I think like an embedded system engineer, I'll actually just have temperature sensor, a microcontroller, and the actuator, which in this case is the fan. So the normal way of doing the embedded system programming is like my temperature sensor will collect the temperature data, give it to the microcontroller, and the microcontroller in turn is going to alter the speed of rotation of the fan. It's going to switch on a fan. Probably if you need some heating, it's going to switch on a heater, and so on and so on. So like that is the traditional way of doing things, where you like have logic, and yeah, logic says if this happens, get to do this. So basically we can say that your system is thinking for itself. So it has some sort of logic. It's guided on how it's supposed to perform. If temperature is above 30 degrees Celsius, turn on a fan. But now with the help of machine learning, you can just give it data, you can just collect data and leave the decision making for the device itself. You don't have to write any sort of logic, you just collect the temperature data, and yeah, the system itself will decide whether or not to turn on the fan, to turn on the heater, to alter the speeds of rotation of the fan, and so on. So basically that's machine learning in a nutshell. So yeah, it's giving like computers the ability to make decisions for themselves. The traditional way, you have to write logic. So yeah, basically we have three major types of machine learning. And the first one is supervised learning. Yeah, I think these words explain much more on what these things are. So yeah, in machine learning generally, we are dealing with data, be it an image. If it's an image, that image is going to be converted into numbers before you can actually do some processing. So like in machine learning, we are dealing with numbers. So for instance, if it's an image, it's going to be converted into an array, a multi-dimensional array. Probably for those who are not familiar with programming terms, an array is like a matrix when it comes to mathematics. So an image is usually converted into a multidimensional matrix. So basically, machine learning is all about data, and we have two types of data when it comes to machine learning. You have data that you feed into your system and data that comes out of your system. So the data that you give into your system, that you feed into your system, it's called features, and data that is coming out of your system is known as labels. So we have features and we have labels. So I hope that is clear. So for supervised learning, we can say that the training data is labeled. That means our features is labeled. That means if back to my example of an automatic air conditioning, but this time with artificial intelligence. So this is an example of how we can train our data set. So we are going to give maybe if temperature is 30, so you're going to have data and a feature and it's labeled. So you can say 30 degrees Celsius on. That means the fan is on. And probably you can even continue further and proceed and say speed is maybe 2000 revolutions per minute, RPM. So that is an example of a labeled data. So you've given it the input, which is the temperature, and you're giving it the expected result, how you want it to run. So yeah, so let's say 30 degrees, you can say 30 degrees, then you will say on, because you want the fan to be on, and then you're giving it a particular speed. So basically that's supervised learning. You have your input data, which is labeled. You have input data with some expected results. And yeah, this is one of the most common machine learning approach that is used. So, and yeah, it's the one with the highest accuracy because you actually, because your data set is labeled, so it has the highest accuracy, and you can get as high up to as 99 point, probably 9% if you have a lot of data to train. So yeah. Maybe I can just give an example of supervised learning. Maybe you want a system that is going to tell how much rent will someone pay. So you will probably, let's say, yeah, house rent. If you want a system that is going to predict the house rent, you're going to give it maybe the size of the house as an input data. You're going to give it maybe the area, maybe the location, the geographic location. Yeah, you can just think of anything. So supervised learning, you just know that your data is labeled. And then we have another one, which is unsupervised learning. So unsupervised learning, of course, is definitely opposite of supervised learning. Supervised learning is, we said that input data is labeled. So in this case, the training data is not labeled. And for that, it's only used in special categories and in special algorithms such as anomaly detection and things such as clustering. For instance, Google, YouTube, to be much more precise, uses unsupervised learning to make a cluster of users who like watching the same thing so that they can get the same recommendation. And then we have this other type of machine learning, which is actually my best, and it's known as reinforcement learning. Reinforcement learning, in this time round, the data it is training itself actually. You just give it data and it's actually training itself. So in reinforcement learning, probably I can share another slide so that you can get to understand better. Yeah, so I bet you can all see my screen. So in supervised, we have something called an agent. We have we have the environment, we have an agent, we have the state, and we have a reward. So you can see, for example, here we have a cat, and probably you want it to achieve task A. So the state is the action. So what will happen? So if this cat moves forward, if it moves towards the right direction, you're going to give it a reward, and that reward is going to be directly proportional to the achievement it has made. So like, yeah, it's more of like giving it a reward based on its performance. So you want it to do task A. So if it's closer to task A, you give it a reward. And if it goes away from the task that you want it to perform, yeah, you kind of like punish it. So you either reward it or you punish it. So this is reinforcement learning. So like, yeah, this is data that trains itself so as to get to do a particular task. So yeah, that's reinforcement learning. And yeah, I think, yeah, I've tried to explain the three major categories. These are some of the applications of machine learning. We have handwriting recognition. We have language translation. Language translation, there's this particular thing called as NLT, which is natural language processing. So we have natural language processing. So yeah, the likes of Google. I mean, that's for speech. Sorry, that's for speech, and yeah, as well as language. Yeah, we have NLP, natural language processing. So the like of Google Translate, the like of Siri, Alexa, and all those, they use NLP. We have image classifications. Yeah, this is more of now deep learning stuff. To be much more precise, CNN. Before the end of all these sessions, you will get to understand clearly on all those different technologies that I am talking about at the moment. So yeah, these certain things, we are also going to cover them before the end of the overall sessions. Yeah, we have like the measurement of success in machine learning. We have true positive. You're going to understand all these things and how they work. Yeah, so don't worry about that. And yeah, I think something else that maybe I should mention is that Python is the language of choice when it comes to machine learning, because there are a lot of libraries available and a large community to do that. But that doesn't mean that you cannot do machine learning or artificial intelligence naturally using any other programming language. Python is preferred because it has a lot of libraries. You won't have to reinvent the wheel. So yeah, instead of doing all those dirty maths that I just mentioned, yeah, Python will do all those dirty maths for you. And yeah, those are the libraries. And yeah, it's easy to deploy in Python because especially if it's a web application, we have a framework known as Flask, and you can easily deploy your machine learning model in the web using Flask. But yeah, I know there are guys who prefer using JavaScript. So Google is on our side because they also love JavaScript. So there is a library called TensorFlow.js. TensorFlow.js is for people who would wish to deploy their machine learning frameworks. I mean, their machine learning model using JavaScript frameworks like Node.js or just native JavaScript. And yeah, probably the last thing that I might mention is, yeah, maths. So it's not a must you get to understand all the dirty maths behind it, because like I just mentioned, all these libraries will get to do the work for you, but it's good to know. I think the basic foundation of machine learning is two subjects, two mathematics subjects, and that is probability and statistics. Again, I said machine learning deals with the data sets. So statistics, by statistics, I mean analyzing the median, the mean, the interquartile range, all those stuffs. So that is basically statistics. And then for probability, machine learning, artificial intelligence is all about making ideas, making predictions, and all those kinds of stuff. So again, probability is also good to understand if you want your journey in machine learning to be smooth. So I'd recommend probably you can just get to understand some basic probability and statistics, and then the libraries will do the work for you. You won't have to get to do the dirty maths, but yeah, it's also good to understand where the things are coming from, or how the libraries themselves are working. So I think with that, I'll stop sharing. And I think I'll take it back to Engineer Ngogi. And yeah, I know it's about the question and answer time. So you can prepare your questions and we will be glad to answer them. So thank you.
Thank you, Max, Patrick, and Evelyn for that informative session. What I'd like to ask you is, if you're a startup and you are working on devising a solution to a problem that you have, what would be the methodology that you would follow to understand what type of machine learning you require to move along your product? Maybe if you can just give us some insight into that, that would be great.
Thank you, Latif, for the question. So again, different problems are solved by different machine learning models. So I think again, probably I should again speak about maybe just whatever Patrick had mentioned earlier on. We also have deep learning as a subset of machine learning, and in deep learning we have neural networks. He tried to explain that. And in neural networks, we have, I can say, 3 other subsets, and that is the ANN, artificial neural network, we have the RNN, and we have the CNN. So again, we have all these like different technologies, all under machine learning, all under artificial intelligence. So again, that will depend on your problem. So let me like try and see. Let me see if I can give you like, let me come up with like different real-time examples and see how we can try and solve them. So for example, maybe you want to make an application that is able to detect whether your crops are infected with a disease or not. So first of all, there you see that your data will be mostly made up of images, because you want like an image classification solution. So first of all, that's an image classifier. And in image classifier, now there we come to CNN, because CNN is like particularly meant for image classification. If your problem again is a repetitive task, we will come to RNN. If you are all about like clustering, anomaly detection, you will come to unsupervised learning. Yeah, I believe before the end of the 4 days, we will like get and see examples of all this stuff. We actually have some Jupyter Notebook example that will help us to understand like exactly the different models and where to apply each of them. But again, the model you use will again depend on the problem that, or the challenge that you're facing, from the data set to exactly what you want.
Great, thank you for that. And that actually leads me to asking another question. When you're applying, thinking about analyzing data in your solution, what are the resources that one has to consider to be able to get the best benefit or the most benefit from machine learning and AI? So here I'm talking about, is there a cost from hardware? Do you need a specific set of hardware, something that like a very powerful computer? Do you need access to big data system or cloud servers? If you could just frame that a little bit, so that way the startups can understand what type of resources they require to get started in applying machine learning. Thank you.
For sure. Sure, that's a good question. So probably, okay, I'll try to relate this again with IoT. So we have edge computing and we have cloud computing. So edge computing, so this is where your IoT device, your embedded system itself, is capable of running some machine learning model. And yeah, the device itself can run some model. We have a library from Google and it's called TensorFlow Lite. And yeah, the light part is to show that it's able to run in a small hardware, just like a Raspberry Pi is good to go. And Arduino Nano BLE is also good to go. We have so many hardwares that are able to support TensorFlow Lite. So if you're thinking of like including edge computing, that is like machine learning on the IoT device itself, there are so many options. You can go either for a Raspberry Pi, you can go for Arduino Nano BLE. Yeah, and the list is endless. Hopefully we'll prepare a list of all the devices, of all the hardware devices for IoT that can support machine learning. And then the other thing, the other category is cloud computing. In cloud computing, yeah, edge computing, cloud computing. Cloud computing, it's all done in the cloud, as it says. So yeah, if it's in the cloud, you have to deploy it. I think I mentioned earlier on some things of deploying. And again, it depends with the complexity of your algorithms. If you have some really heavy CNN, and by heavy, I mean, I think Patrick tried to explain about the layers. He showed that if you want a higher accuracy, you will have so many layers when it comes to neural networks. So if you have one which is having so many, if you are aiming to get 100% accuracy and having a neural network with so many layers, I think, yeah, an SSD, a virtual private server will be good to go. Yeah, you can just use a virtual private server, or you can use the existing AWS architecture for deploying your machine learning models. Thank you.
Thank you very much for that answer, Max. I'd like to open up the floor to anyone else who has a question on the content that was shared today. Okay, well, if we don't have any questions, maybe Max or Evelyn or even Limo, if you could just let us know what you'll be covering tomorrow in our training session, that would be great. And then we can sign off the training for today.
Okay, I think I'll just mention what we will be doing tomorrow. So today it was just more on the fundamentals of machine learning. So tomorrow we are going to do the fundamentals of IoT and which IoT technology to use for a particular problem. So tomorrow it's going to be all about IoT. So yeah, let's meet tomorrow, and yeah, carry your pens and notebooks.
Great, fantastic. So I think that comes to the end of the session today. Favor, I think maybe you can sign off, and then we'll be back tomorrow at the same time from 2 up to 3:30, depending on the questions that we have.
All right, sounds great, So thank you all very much. Thank you to the Chief Chirono and the Gearbox team for that session. So thank you to Evelyn Otieno, Maxwell Washira, and Patrick Limo, and for all, this entire session really, and then tomorrow's session as well. So Have a lovely evening and see you tomorrow.
Great, thanks. See you tomorrow.